So hello and welcome. We are continuing on Book Club, and I'm joined by Matt today. So nice to see you again. We are going to cover chapter 11, which is kind of a lightweight chapter, and start getting into 12, because 12 has a lot of detail to it. So, and as always, I'm recording, and so if you are following along via recording, welcome to join in. So I'm going to go ahead and share my screen. So it's interesting how the book author goes from the conceptual to the pragmatic. And, it's easy to be a critic, right? It's hard to write a book. In my opinion, the conceptual is too long and the pragmatic is too short. So that's my 2 cents worth here. But obviously the book as a whole is highly valuable. I wouldn't be putting this much time into it, so I'm not complaining that much. But chapter 11 in particular has basically one idea, which is an important idea, but I think it could have been a section. That's why I'm going to go relatively quickly. In the scale of things, we came out of how to design the architecture, and now we're in really the key meat of the book, which is how to design the data products. And we have the 4 chapters in here, which is design a product by affordances, which we'll get into what that means. And then 12, which to me is one of the most meaty chapters, which is design, consuming, transforming, and serving data. And we're going to do serve data today as part of this meeting. We'll do the consume and transform in the subsequent weeks. And then 13 is design, discover, understand, and compose. And 14 is manage the life cycle, govern, observe, debug, and audit. So to me, as we go through the concepts, 12, 13, and 14 are really the as would be typical, the end of the book is usually the key part of it. And then there is a section, how to get started. I don't know as a book club if we're going to get into that very much, because this is, again, very conceptual. And I'm not as interested in that point in this area right now. So I think for the remaining meetings, we're going to really just dive into chapters 11 through 14 with demos as much as possible. So,
well, that's where I like the demos, because that is the real world conceptual. And I love how you're showing things that 3 weeks ago didn't exist. So.
Right, exactly. So that being said, let's take a look at what this chapter 11 has to say. So this, central idea that we're creating data products, which I think of them as microservices for analysis. And she has the term architecture quantum and data quantum because it's more broad than microservice. And I understand her point. Implements all behavior and structural components. And then you have interconnection. I probably wouldn't use data quanta with my customers. To me, it's too fancy. I would just say microservices. Yeah, too abstract is a good way to say, yeah. So, so this chapter 11, the idea here is that you want to basically design data products for the users. That's what by affordances means. It's a fancy word for by how it is being used, which is, an obvious common sense approach, but one that unfortunately in analytics is still, I find, to be the exception rather than the rule, which is really kind of sad, because it's a common situation that when you are a data steward, which I think everybody that's participating in this group kind of is, it's easy to get focused on the data tasks, like managing the data, optimizing the data, securing the data. And I think the whole point of this chapter, if I were to put a title, I would call it "Don't Forget the User," and I've been guilty of that. We all have, right? But, maybe because it's a new paradigm, and so, we all tend to fall into our old habits, which is, okay, how do we secure it? How do we ETL it? That kind of stuff. And she's saying, no. You first have to think about the user. So she's, saying basically DataMesh has data products that are self-contained, autonomous, and co-equal nodes, data quantum on the mesh. Each data product is designed to be self-sufficient, affords its users and developers all the capabilities they need to do their job: discover, understand, use, build, govern, and debug. And that's very fundamental principle of any data solution that is so often overlooked. So I don't know what you think about this sort of thinking, Matt, if you think this is necessary or.
No, it's true. I think as engineers, we love to engineer,
Right.
And our end users don't see the details behind the scenes, and so I'll get wrapped up in the details. Well, you have to secure it this way. We don't care, and so I think I take on some of that aspect myself because, like building the foundation, I'm not going to release a house to you until I've built it structurally and add things. But it is very easy to get wrapped up to that, and suddenly I've built a system that's a little hard to use and doesn't quite do what they want to do because I forgot who the customer was. I became my own customer there for a little bit.
Yeah, well, the push-pull is very difficult because data engineering should be transparent. And the challenge with being a data engineer is it only gets customer notice when it goes wrong.
Yeah.
And that's the real challenge because the value of it is not seen until it goes wrong. But yet there's quite a lot of work to secure data correctly, to scale data correctly, so on and so forth. So anywho. So here's her concept of affordances, the relationship between the interfaces of data products and how people or systems interact with them. For example, how data product affords its users or programs to connect, subscribe, continuously receive. Another example is how data users, people or programs can discover. So can they find it? Can they use it? Which, again, sadly needs to be written in our industry, which is sad, but I find that to be true very, very often because the greatest data set in the world is worth nothing if the user can't find it or use it.
Mm-hmm. Yeah, definitely.
Right? So, and her thing is designed by affordances. And then she just talks about how this is so important, la, 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 la. And then I always like her diagrams. So basically you have your data product, which to me is your noun, and then the activities that surround it are the verbs. So you have a data product, in her example here, like something like a playlist, and then you are going to have something that governs it, something that serves it, something that consumes it. Not all these are going to be in every case, but these are different common options that you would want to figure out. Is this going to be necessary? Something that transforms it, discovers it, if it's composed, life cycle, observe, debug, audit, and govern. I'll just mention life cycle because in genomics, this is something, cloud genomics, that I am always working with customers on because many customers are coming from storage solutions that operate differently than cloud buckets. And so the concept of life cycle policies on cloud buckets, which is basically just archiving, but it's implemented differently, often causes customers to not implement it at all. And so as a consultant, I made many a dollar with people saying, oh, my cloud storage bill is shocking. And me coming in and going, well, basically you've left it all in hot storage, right? Yeah.
That makes sense.
Yeah. So this sort of 360 view of data, this is not new at all. This is nothing new to me. This is all these disciplines should be part of working with analytic data, nothing new to mesh, and they're not. And maybe the point is, as you're designing your data product, you want to very deliberately look at all these so you don't miss them. And that's how I take it, basically.
No, that's true. And then like any other project, you see a nice project list and you ask who all the stakeholders are, well, the inputs and outputs and things like that. But when we just create things without a nice list to look at, we'll forget to ask some of those questions. And I can't tell you how many times we've built a data system for people and questions like, well, what is the life cycle? How are people going to discover this? Those aren't even asked because there's assumptions up front on how it's going to be used. And only we find out 6 months later, you forgot a couple of pieces because you didn't have the checklist in front of you.
Exactly. Well, I think that this is a good starting point. And like you're saying, make a list and then see which things are like ABC, basically, because managers are going to say they want all of them, right? And so you need to prioritize them so that you can have a common communication about when you're delivering them and which ones are most critical. Like in my world, genomics, life cycle is always critical because we're always talking about petabytes worth of data already. So you kind of, that's always A, it should be anyway, you know? All right, so then just like in the previous chapter, she has a nice table here and she's just defining, to me, they're kind of obvious, you know, like serving, consuming, transforming. And as you were saying, Matt, you want to match the verbs to the users. Who is going to be consuming?
Now,
Who is going to be transforming or what?
yeah, totally. Now, some of this I thought originally was part of the product or inside the product, and some of it is outside. So I don't know if she's making a distinction here or what. So like transforming data, discovering data, to me, that's outside the product. I'm a consumer of the product. But life cycle, I would think, would be part of the product or the internals.
Well, the way she sees it, and there'll be another diagram, is that this plus whatever of these verbs, this inside the data set itself is not the data product. The data product is this plus this.
Okay.
Right. Yeah. And that's therein lies the rub, because, you know, more traditionally you have, right, your big data structure, and then you have, well, we have a, you know, indexing service on a website that serves that, right? And that's completely separate. And that then might have, you know, many data sets out of a data warehouse. The difference here is that it's microservices approach. So you wouldn't have, this is not one big data warehouse, this is one data product, right? So, and you might have this, let's say it's a website, you might have this associated, parts of this associated to different data products. So that's the microservice thinking, right? So design for change, responding gracefully to change, easier said than done. But a practical thing here that I have done this is to me kind of old data warehousing stuff, some best practices, adding time as an attribute. So this is I don't know if you've ever done this in building a data warehouse, but I have, you know, when you're doing ETL, adding a load time and a transform time as part of the record. It's for lineage. That's a common practice in data warehousing.
Oh, interesting.
Yeah. So, and then she, and I've done this too, all data products and artifacts are versioned using the notion of time. And so you can either use the timestamp itself, or you can create some kind of GUID or identifier with the timestamp in it, with the product. But again, these are not new concepts. They're maybe new in the world of microservices, because in operational microservices, it's more of a fluid, it's faster changing than in an analytic model. So anyway, then design for scale. So you want to scale out, and then she talks about the sidecar again, which I know I said last meeting that I would work on this, and all I really did is I found an article that talked about an example. I didn't build it yet though, but I did drop that into the Slack, and I'll put it on our GitHub. But it's what Elliot was talking about, where the sidecar is a container that like does logging. That makes sense to me.
It adds an attribute or a side effect.
Yeah. And it's reused. So the sidecar container is reused. Where I want to test this, I think I was telling you, is Google has a service that allows you to do very lightweight container applications. It's called Cloud Run. So basically you just put in the container, and then you twist a couple knobs, like how much memory do you want, how much CPU, how many instances, and you basically have a Kubernetes cluster under the hood, but you're not dealing with the 300 objects. So it's a really nice way to just quickly POC or very lightweight container-based either websites, or you can actually run jobs. So in this sort of data mesh concept, one of the things that's interesting is Google at Cloud Build 2 weeks ago announced that in Cloud Run, you can now have sidecar containers, because the original implementation was one container. And I was like, oh, this is perfect. So now I can try this out with DataMesh.
Wow.
So yeah, so I don't know how that would work in Amazon or Azure yet, because again, I'm just, kind of on the front of it. If I had to guess, Amazon probably already has it, because they usually do. But I will try to get this built in the time of book club, because I think it's actually kind of important to get some examples out there.
Yeah, I would love to see examples, because I'm still, from a data mesh point of view, I'm still lost as to what the sidecar actually would provide. So seeing it actually in context would help.
Well, now I'm kind of thinking in terms of design, like, okay, let's say you're doing an ETL process, part of your data product, and you're doing, let's make it simple, null checks, and you're not allowing nulls in the downstream consumption. And so you might want to have a logger that logs null conversions, because maybe you convert it to 0 or none or something like that, so that you can have provenance, because you have to have provenance of how the data was changed for your compliance. So you have this logger, which just writes these logs out when the ETL process is performed, and then it logs out any null conversions, so that can be easily retrieved if necessary, as a data quality metric. So
yeah, that's true. And then that would be something you'd reuse across your various.
Yeah, you could just pop it into all your data products that you could potentially be loading, having nulls, for example. Okay, and design for value. To me, that's make an MVP. Value means value to the business. So like, get the value all the way to the customer as soon as possible. Design influenced by the simplicity of complex adaptive systems. I've been talking about this for a while in terms of serverless architectures. I want us to get beyond the thinking of it's mechanical, like a car or something, where you have different parts and pieces, like a VM is a hose and a bucket is a belt or whatever, and go to the fact that it's biological, which might sound a little spooky, weird, but properly designed serverless systems have, let's call it nodes, like compute instances or pieces of compute, for example, that are like cells in a living organism. They go up, they do something, they go down, they die. You get a new one, it goes up, it goes down. It's much more biological than mechanical. And I don't know if that's helpful to you, but when I got that in my head, it was easier for me to understand concepts like cattle, not pets, for VMs in architectures.
Oh yeah. No, I agree. And I remember talking to someone who was working with a team that they created, games and apps. And he said they're all very small containers. They're microservices, so they're doing little things. But he said, we might have 1,000 of them running. He said back in the day, we had large servers and we were constantly checking them for corruption or people hacking into them. He said now we blow away everything every 24 hours. But we have monitors and checks. And when the logging system identifies a problem that's out of the norm, he said, we don't even care what the problem is. We just blow it away and restart it. They rebuild it from the image. And to me, that blew my mind, because here now we could have 10 nodes or 1,000 nodes. And it would take me longer to figure out why a bug got introduced. The other 999 are fine. Let's just call it a weird hiccup and blow it away and reload it. And I thought, man, that's so freeing, because if you can, as a developer, say we've got a tried and true product, it's well tested, it's well developed, it's in the wild. Any errors that we see that aren't across the whole series of them can be attributed to weird hiccups. You've got a weird linkage that's wrong, orchestration that didn't work out right. Just just kill it and restart it. That was very freeing to think of that.
It is. It is definitely an evolution in the way I work with cloud computing. And it's a big bar to get over, because I had my own hesitation till I got there. So I'm sympathetic with other people. But until you get there, you don't really realize some of the economies of cloud until you can pass over that. Because when you're still thinking of managing VMs, for example, you're going to have more cloud spend, and you're going to have more effort with not business value.
Yeah, totally agree.
Yeah, so no central orchestrator. DataMesh, like the complex adaptive system, she said a flock of bird, doesn't need a central controlling architecture. Okay, yes and no, because there is, like in all these cloud implementations, there's organizational level policies, okay? So there is control, but it is a mesh. It's not a hierarchy. So like she's talking about flocks of birds. They don't have an orchestrator, but it has a set of biological standards. So that would be the organizational policies. And here she does say global policies, right? So that is one of the hardest parts. All right, so that pretty much wraps that up.
I'm not sure if it was me or you, but on my end, you froze for about the last 60 seconds.
Oh, okay, sorry. Well, I was just covering the fact that figuring out how to set the org policies is I'm finding to be very, very difficult. Definitely. And we'll go back and look at that in chapter 14. Okay?
Cool.
All right. So now in chapter 12, we are now getting into the nitty-gritty, right? Which is design aspects of this data product. And these are basically the things that are going in the circle around the data product. So these aspects that she covers here are consume, transform, and serve. Again, I would kind of disagree with the order, but I'm going to go with her order, because when I think about it as a data architect, I have to first think about the quality of the data. So the first thing I would probably do is transform. Because if the data is of a poor quality, nobody should be consuming it. You know what I mean? And I've certainly seen a lot of that. So like what I would typically do when I was building a new data analytics solution of any kind is I would do data sampling with end users to try to get an understanding of the quality of the data before I could be talking about how you're going to be consuming it or serving it up. And again, I think this is just years of practical experience, because all data is dirty, right?
You probably had a sense of how they were going to consume it, right? Because I'm sure they weren't consuming 100% of the data available.
Right. Well, that's why I usually start with transform, or maybe raw data is what you'd call it, right? Like I'd start with raw data. Like usually what I actually do, and this goes back to my data warehousing days, and I've done a lot of consults where you just go in and help build, it was pre-cloud data warehouses, basically. And it's still the same process for any sort of for data lake or data lake house, or it's the same thing, which is a data survey. So when you come in, the first thing that you do is you try to understand where the data is, which you might think, well, doesn't the organization know that? Well, they often don't. So you have to kind of like, where is the data?
Yeah.
And then which prioritize the data, which data is of the highest value, and then start looking at sample that data so you can understand how people are currently using it and what is the quality. One question I always ask in all my analytics consulting, and I think it's very relevant whenever there's a new paradigm, is when at that early phase in sampling the data, is what information can you not currently access? So I don't just base my design on here's the data, let's do something with it. I also ask the sort of encapsulating question of, like, what would you like to be able to do? Because what is now possible for some domains, and I'll use genomics as an example. I'll use a very specific example. So cancer researchers for genomics, they use reference genomic data. Like, here's a DNA sample with the variants, and here's a whole bunch of them, and we're going to compare this to, you know, the current patient. Okay, so it's well known that breast cancer has certain types of breast cancer has genomic correlations. BRCA is, a lot of people have heard of it, the BRCA gene variant. And I'm oversimplifying, but just to get that kind of idea. So before we had environments like data meshes, what customers were doing is they were downloading the reference data set, which took, depends on their capabilities, days or weeks, the TGCA data set. And to make it worse, each group would download it.
Yeah.
So like one research organization I worked with, they had 10 different copies of TGCA, right? And so what I said to them was, there are a lot of tools now, because it's hosted on Amazon, Google, and Azure as a public data set, that now you can just put in a bucket address and you don't have to download it anymore. And I think they wanted to kiss me. Because it blew their minds. Do you know what I mean? And so that's,
but they didn't have to have their own copy.
Exactly, right? Yeah, and download it and update it. They could just go to the website and point to the bucket and get the most current version and just start working, right? So as there become these different possibilities, and public data sets are one of them, it's important when you're designing to talk about what is possible with some of these new capabilities. Another one is being able to pull down reference data that, like, I had one long time ago, I had Dun & Bradstreet as a client. And obviously their livelihood is data, it's proprietary data. But they, like many other people, have become cloud native. So similar to the TGCA example, you can now access their data. You'll have to pay for it, but it's much, much more in the reach, because the vehicle is so much easier, the cost is so much less. So the whole point of all these examples is you have to figure out what are the business problems and what data would be needed, and go beyond the what data do we currently have. Go beyond that, because there's so much more possibility now. So
nice.
Yeah, so okay.
One of my favorite questions when I'm working with a team also, especially like, so on the IT side, when we're automating, and we'll have two different groups and they both have their own set of data, and they think the data is the same, but they're pulling out of two different systems. And so you always have that invariable problem. Well, what are some of your hardships? What is it that you're trying to solve? You know, well, you know, sometimes when an employee changes their street address, so now their bank account and whatever stuff we're sending, well, who does that? Well, that's HR sometimes. Well, wait a minute, what do you mean by sometimes? Oh, well, if they're blah, blah, you know, and there's different things. And then we're dealing with financial systems that we have no control over. And apparently there are payroll windows where when they're actually cutting paychecks, you know, figuratively or literally, they lock the system because they don't want you making changes in the middle of a payroll run that affects 100,000 people. And so we find out that there's different databases that people are using. And so the question we always have is, well, what if they disagree? Who wins? And I love that conversation, because each side immediately thinks they win. And no. And so we'll mediate those conversations, but it suddenly opens their eyes that when you have multiple sets of critical data, somebody has to decide who wins. And maybe sometimes of the months, one person wins versus the other. And those are, I enjoy those engineering questions. But whenever we try to automate and you have data discrepancies, it's not just one's dirty and the other one's not. It's okay, well, where's the value? You know, who wins if we only have one bucket to put this data element into, and they disagree. So, but I love having those conversations with the clients because they don't think in those terms. And it helps them understand, because usually the reason why the data doesn't agree is because there's a disconnect between two different departments, and they don't understand how they actually work with each other. It's only when IT comes in to automate things that they realize that their business process is dependent on the other one.
Yep, we're a forcing function. Yes, I've been 100% there. The other thing I would say is sometimes when people wouldn't agree, that's when I would put timestamps. And I would just timestamp everything. And then it would be like, okay, everything's there. I can put timestamps. I can put where the source is. You can query it, and you can do whatever you want. You know, if you don't have a consistent agreement, I'll just put all the data in there with all the attributes, and then you can figure it out. Because I have had engagements where we just can't move forward because there's too much political fighting. And so that's a way around it, by just adding more metadata and saying it's all there.
That makes sense.
Yeah. So, all right. So we're talking about the needs. So here is the big idea, which is that you have your data, and then here is the different ways that you would access it. And she's going to make this more and more concrete as we get in this chapter, which I like. So, so the data sits here, and then you have different types of access to the data. Going after the conversation we had, which is skipped, which is what is the raw data? What is I call it the aspirational data? What goes in here after you assume you have that, right? So then you need to figure out the access. So what are the priorities in terms of access? And here she's kind of categorizing multimodal for the different users, bitemporal, and that's a fancy way of saying what I talked about in terms of having all the different data, and then immutable read-only. This shows her experience. This is another trick up my sleeve. It's an old DBA trick. Way back before there was data warehouses, you just make a read-only copy of the operational database and sync it on some time frame, and let all the report writers write against that. It was usually like, this is really dating me, but like it was usually overnight. You do a batch job overnight, and then the report writers can write any stinking SQL query they want. You don't care because it's not hurting the operational system. And that pattern remains. It morphs into something more fancy in the cloud, but that pattern remains, that read-only copy of data. That is often a very, very good solution, so long as it can be a subset.
Yeah.
And you have the point in time. That's the other tricky deal, because if you're going to have latency, and you have to make that very clear. What I used to do, because I'm so old school, again, I feel like this is a nostalgia this week. I used to literally put on the top of the report last synchronization date and time, like in red.
And we would do the same thing. And someone would come with a report saying, how come our numbers don't match? And I'd be like, well, look at the top.
I know,
but that helped us too, because for some reason, you've got logging, you've got notification systems, everything, but every once in a while those break down. And so we would go pull data, and how come the user isn't in there? They were created 3 days ago. And then you go look at the timestamp and realize, oh, wait a minute, this data is from 5 days ago.
Yep.
Something, but it was because, like you mentioned, you add that timestamp when you pull it. Yeah, and we do the same thing.
Yep. Practical stuff here. All right. So, okay, consistent. We just talked about that. Okay. So, all right, so the properties: multimodal, immutable, bitemporal, and read-only. So multimodal. The job of the data product is to serve the data domain with a unique domain semantic, okay? It must, Okay, so it's saying that you might have to put it in different formats. So, or there might be data in different formats. You might have relational database tables. You might have columnar storage, you might have document storage, you might have event storage, you might have graphs. So this is a relatively new concept to aggregate the data by domain in multiple formats. This is pretty advanced. Usually in the past, it would be, your data would be separated by data type. I agree with her, actually. This is how users want to see it, right?
Mhm.
But to actually do this is pretty hard. To make a data quanta that has documents and tables and graphs and events all consumable by the different verbs, if you will, is non-trivial. So she talks about using APIs, but again, she's kind of skimming over the important detail of writing an API for event-based data versus writing an API for graph-based data is a totally different skill set.
And this probably goes back to her data quanta also, but to me, at least in our world, almost everything was already in a relational format. But when you go to cloud and API, everyone's like, well, APIs suck, REST API. I've got to run 50 million, requests to get the same thing I could have gotten with a really nice join. So how did we approach that? We created a graph interface in front, but that had nothing to do with the data system. It was an add-on. And then, oh, well, now I want real time. Well, are we talking about change data capture? Are we talking about, but that was another add-on. It was something outside. So if you're developing a product that has all of these touch points built in, I do see that being attractive. It's not an add-on that breaks.
I do too, but in my brain, I kind of go, how does that exactly look? Right?
Yeah. Oh, totally.
Because I try to map that to systems. So I'll make an example of a system where I think it works. Okay, so in Google Cloud, you can have cloud storage buckets, and then you have big query data sets, which are cloud storage buckets that have schema, right? So there's a new thing called Big Lake, where you can keep your data in your storage bucket, which is cheaper than a BigQuery data set. And it's usually like where it starts. You don't have to move it. And then you can keep your schema in a centralized data storage. It's called a Hive Metastore in Dataproc. It's like Hadoop Spark. So instead of having like BigQuery data set where you have like CSV file and then schema, and that's a data set, you have all your data is in a bucket or buckets, and then you have all your metadatas in a database, and then that is shown to the user as what's called Big Lake. So it just looks like a cheaper data set to them. It looks like BigQuery data sets that don't cost as much and that you don't have to move anything. And that is a pretty elegant example of it, because you can have BigQuery data sets, and then you can have big lakes, and then you can have files, right? That's
all the same.
Right. And you can query it all using BigQuery, basically. So, I mean, files, you'd have to have some sort of schema or structure, but you have multiple, whereas like I think of files could be like events or graphs. Again, I'm not probably being specific enough here, but through this BigQuery ecosystem, and all the data warehouse companies are starting to do this, like Databricks has Delta Lake, which is kind of like Big Lake, and Snowflake DB has Snow Park or Snow Lake or something. So the idea is you have buckets, and then you have the query engine, and you can just have the metadata stored in a separate service. So you don't have to move data around. So smart buckets is what I call it.
Okay. Yeah.
So anyway, okay, so this is the key idea. She takes her abstract and she makes it an example. And I think this is a pretty good example. So she has her data product play events. I'll just say play information, because it might not just be, might be more than events. And then based on the needs of the company, there's 3 different user personas, and the app developers need the data access through PubSub so that it's near real time for their website, let's call it. The data analyst needs to access via SQL. So that would be like the BigQuery case I was just talking about in Google, and they make a report and they visualize it in Looker. So in Microsoft, that would be like a Power BI kind of situation. Yeah. And then the data scientist is doing machine learning. And so they're using a subset of the data for their model training, or a certain time slice of it. Like it's all the events are flowing here. This would be kind of a windowed aggregate.
Yeah.
And then this would be maybe a subset of the features of the events. Like if it's very wide and their model is like if they're collecting, I don't know, let's call it 100 different features, and their model only needs like 15, then they're going to do a subset sliced this way.
Would that be similar to like a SQL query? I mean, they got to query the data, but they're getting a column or aggregated set that only includes the features.
Yeah, I mean, basically, it's funny how the different domains, it's like different taxonomies, it's different words, right? So they call it feature engineering in model data preparation for machine learning. And really, that's very conceptually similar to writing a SQL query. That's a subset of an underlying structure, because they just want a subset of the data, basically, right? And this, I like this because I think this is very applicable to a lot of cases that I've seen. So you have events, and you're going to have 3 different ways that your different personas are going to consume the events. Some need just all of them as they flow in. Some need these reports, and some need machine learning. And it's interesting to me who she puts as the user, because the user, this is the developer. The user sits over here. This would be like the public. This would be like the manager, and this would be like the scientist. Maybe, I don't know, the lead scientist. So this is the dev layer here. This is not the end user layer, which I would kind of quibble with. That should be over here. Do you know what I mean?
Yeah.
Because that's who we're designing for. This is actually a common fallacy that IT has. We design for developers rather than end users.
Oh, I see.
You know?
Yeah.
And then end users are like, but I can't use it.
Maybe we're throwing it over the wall to the app developer, saying you make it consumable.
Right.
App developer, that's the UX side of things.
And again, to kind of like pull this into an actual architecture. So this would be like, this is a Kafka stream, let's call it. And off of some, I don't know, devices or whatever, captured. And then this goes into buckets. And these buckets then have, I'm taking a Google architecture, functions, which are like lambdas. So they're little slices of compute that when something comes in, it then triggers off something else. So you can trigger off, they're like database triggers in a way.
Yeah.
You can trigger off sending an event to a PubSub topic, or you can trigger off a point in time or query, or when you have a certain number of events that could trigger a query. Same thing here. When you have a certain number of events or at a certain time scale, you could send out for model retraining as a job. And this in Google is called Vertex AI. It's like the SageMaker for Amazon, and I don't know what it's called in Microsoft, but it's like managed machine learning,
Yeah, I think they call it Synapse in Microsoft. But they got several flavors of that, and then they have that data for that hexagon there. With at least what I saw demonstrated to me, and I'm still brand new with this, but what demonstrated to me on Monday was you would create an actual you create a lake house individually, but you have your ingesters and everything built into that, your orchestrators and everything. But at the end, with the data set you create is the product. And then they have what they call data activator, which could be the PubSub. It's literally monitoring anything you tell it to monitor. So when the data changes, it can trigger events or send out to an event stream, what those changes are.
Mm-hmm.
You got the SQL endpoint. The ML model could be built into that, or it could be a consumer outside of it. But yeah, you've got your buckets built in. You've got your orchestrators. You've got your data set as the output. You've got your activator for the event streaming. But that's all built into one lakehouse. And what they were trying to at least recommend is you have one lakehouse per product. And so that's where it hit home to me that you were talking about. You've got your compute, you got your orchestration, you got your buckets, you got everything in one area. And then you have as many lake houses as you need. So you could have a dozen or more, whatever. But you don't have one giant lake house providing several different products. You have one lake house per product. And I thought, oh, okay, that's starting to hit home, starting to make more sense.
Well, it reminds me of when I did OLAP data warehousing, when you do data marts. It very much reminds me of that, which is you create subsets for the business unit. Now, this is even more granular because it's the level of the product.
Yeah.
But it's, and I think definitely it's a new flavor to have machine learning, because that was a specialty side case, and that's integrated in a lot of cases now, which is, different. But I think that that's what I think of it, as like a more granular data structure that is departmental, maybe more than one. So, okay. And this is very important. Again, some of this stuff is like, to me, old data warehousing. I can remember, this whole meeting is just nostalgia. I can remember way back when building data warehouses and people talking about, well, how do we correct the data if it's wrong? And I said, you don't. You just put in a new record with a new timestamp.
Yep.
That would freak people out. But that's actually kind of an old data warehousing thing. You do not change the data.
Well, I love how she says here, data users can rerun analytics in a repeatable way. I mean, that's like going back to functional programming and other things.
Yep.
If your input keeps changing, how do you ever ensure that your testing and your models are correct?
Yep. Yep.
So no, that makes perfect sense. You have to have a sample that never changes.
Yep.
So that as you make adjustments, you can rerun it.
Yep. This is not new, but as you add complexity, as you add pieces, this will become more important. So this is extremely important. No changes once you get it into the data product. You just add, you do not delete, you do not update. It's add.
Well, and going back to your statement of, you keep adding a new record with a new timestamp. I remember, so I was dabbling and learning about Clojure a little bit, and they were talking about their databases, and that's how they ran it. You always added records. Everything was immutable.
Yep.
And the idea back then, and we're talking a long time ago, well, shoot, who's got the storage to do that, right? But it hit home, and they were like, realize a traditional database, relational, that is not a long-term database. You are looking at a point in time.
Right.
And what do? We update records. Well, you should never update a record, ever. You should just insert. And then whatever you're querying should query the most recent insert. That way you can literally look at a point in time at any time. And when I heard that, I was like, oh my gosh, you're exactly right. We are destroying data. We are destroying information that up until 2 seconds ago was deemed to be correct information, and we've just destroyed it. So that's when I see normalization, and you have this sprawl of tables. Well, why? Well, that was correct 15 years ago, and we have a date timestamp on it, so now I got to join against it in some crazy way. But
I don't think that relational databases will ever be totally gone. It's really interesting because in the industry, the big scale players like the Googles of the world, they don't use relational databases because they're going for scale, right? But I think because there's such a known paradigm and they handle transactions so well. I always say put your money data in a relational database because you're transactionally consistent, right? But it's your hot data only. Once your data is no longer hot, then you move it to an analytics solution that, in this case is a mesh, and then you store it in an intelligent way with a life cycle. That's really my world these days, that you need to have the life cycle. And cloud vendors have that. and they continually iterate on it. I mean, I think most of them have like 4 or 5 tiers of storage now, and they're dramatically different in price. And again, customers just haven't quite kept up, and it's really cost a lot of my customers. I mean, it's been commonplace for me to save people $20,000 to $50,000 a month by implementing this. That's how big of a problem it is.
Yeah.
So
I see it. That's cool.
yeah, yeah. So, all right. So what is this thing? This is correlating inconsistent data. Okay, fine. We talked about that. Immutability is a key enabler of design for change, maintaining eventual consistency of the mesh. Yeah, because like you said, you can't, if you're changing data all the time, you'll never get there. And I've had projects like that took just forever because they insisted on making it, being able to make corrections. And they just, it seems like it goes hand in hand with the amount of messy data that the company insists on making corrections, and it makes their data messier and messier. Do you know what I mean? Yeah. So, all right. So the next thing is bitemporal data. So it's a way of modeling data. So every piece of data records 2 timestamps. This is kind of cool. I like this. When an event has occurred, or a state actually was actual time in combination of when the data was processed. This is very formal, and you'll probably get some developers will be like, oh, that's so much storage space. But is it really?
Not these days.
Is it? Right?
Yeah.
Yeah. I mean, I understand, you know, in the beginning it was, but I like this. I think it's well written.
So they're saying that, yeah, you want a timestamp of when you pulled the data and then a timestamp of when it was processed, because I guess that could be seconds, minutes, hours apart.
Yep, exactly. Yep. So it's more, this is more precise, which I like.
I guess we never cared about the process time. We just pulled the actual time, and that was, like you mentioned earlier, that was what was on the header of the report. Right,
right. But again, as you get more microservices, you're going to get more complexity. You can get more latency.
And if you're doing event streaming, you might assume that when you're consuming that next event, it is real time, but it could be.
Yep.
And with your dealing with financial transactions, you know, even seconds are important.
Oh, microseconds.
Microseconds, yes.
Microseconds are money.
I love how when they built the New York Stock Exchange and they had the data centers that they they would sell, units to vendors.
Yep.
They literally have all the fiber optic cable is the same length. And it doesn't matter if you're right next to the rack or you're 100 yards away from you have the exact same. There's so much cabling that is coiled up so that every single area of that rack has the exact same latency. I thought that, it makes perfect sense.
Yep. Time is money.
That blew my mind.
Yeah. And this is just talking about SKU, what we just talked about basically. And then windowing, which is not a new concept. And then more about time. Time is a primitive for versioning. We've talked about that. So the more precise you are. And again, one of her cool diagrams. So, which you just talked about, basically. You just described this. So that's all good. And then the aggregates. And then read only. And here, look at that. We're almost on time. Speaking of time, she's evolving the data product. So the data product, the adapters, the core semantic schema that you validate against, the bitemporal data over a long infinite retention period, multimodal read access, the events, the pub sub, if you will, the SQL, the output data port, and then the machine learning. So I don't know if it's clicking into you as much as it did for me, but I was like, oh, yes. Okay, this is making more sense. I want to go try to build one of these now.
I know, I do too.
Right?
Yeah.
So yeah, so that's a good, I think, stopping point.